Good afternoon. All right, so I see everyone in Winslow, everyone in Mogollon. The camera's a little high in St. John's. I think I see four heads there. Are we all good in St. John's?
Yes, we're good. Everyone's
All
here.
right, all right, awesome, awesome. Okay, so let's go through a couple of things here before we uh, get to the math. Um, First of all, I want to show you on the Moodle. So right above chapter 1, there's the course improvement survey, fall 2019. So that's the one that you just point and click, and it's a quick survey. All right, but the way that it's set up, not by me, I couldn't, I couldn't tie it in. I can't tie it in directly to extra credit. So underneath that, it says extra credit for survey. So when you click on that, and it'll just pop up as a one question quiz, true or false. I completed the course survey. You select true and you get 5 points extra credit. Okay. If you select false, then you don't get anything. So wait till you finish the other one so you can answer honestly. All right. So any questions about that?
Yeah, is it just one attempt?
Actually, I made it unlimited attempts. So if you accidentally click the wrong thing, you can go back and it takes your highest grade. How about that? Okay. Is it one attempt? I'll tell you what. Okay, let's see the next thing. Let's Oh, actually, I want to do the other thing first. So just kind of going over what our plan is for this week. All right. So today we're going to finish. We've got 5 or 10 minutes left on chapter 5. And then we want to start in on chapter 6. Okay. Remember chapter 6? If you looked at the guided notes, there's just one page of guided notes for the whole thing. And our focus is going to be calculator tricks. Okay. And for the applications. All right. So that's today and tomorrow. All right. Then Wednesday, this last quiz, during the time that you test, the 5.4 through 5.6 is just one quiz. I combine them together and I'm making it extra credit. So you'll just have one little quiz, and then so in your testing time or whatever, if you might have time to do other stuff like makeup stuff or whatever. But then during class time, that's when we're going to do the chapter 5 test. Okay? So I know you do like an hour before or whatever. So if you want other stuff, that's up to you. If you only want to come in, 20 minutes before class and knock this out before you take the test, that's up to you. Okay? Or you could, make sure you get through both of them twice or however you want to do it. But I am asking you to do that quiz if you want for extra credit. And then the chapter test is during class time. So the last broadcast will be tomorrow. So we'll take that. Then we'll start the final on Thursday and Monday will be the final exam. So Friday or as scheduled. So if you need to make up anything, second attempt, or if you didn't do the extra credit quizzes, if you didn't finish those on Wednesday and you want, then you can do that Friday or just whenever with your talent aid. You just schedule it, let me know, okay? And then, so then the chapter 6, that's the extra credit one, where if you take a 0 on it, it's not going to hurt your grade. So I'm calling it a bonus take-home test. It's going to be open all weekend through Sunday midnight with no time limit. Okay? So it's just going to be extra credit. So basically what you're going to have to do on that is sit down with the formulas, probably with the book, and try the different questions and see how you do. Okay? But it's almost everything is, for the calculator. Okay? So that's the plan. So again, I'm thinking the last broadcast for this class will be tomorrow. But if after tomorrow you guys want to do something, want to alter this a little bit, that's okay too. All right. Any questions on the closing schedule?
Well, so when is the chapter 6 test going to be open? On Friday?
So I'll probably open it after class on Tuesday and then just keep it open all week.
Okay. And then will the 5.4 and 5. The quizzes for the chapter 5, are they going to be open for the whole, like whenever?
Yeah.
Or do we have to email you?
I was going to do it Wednesday. So 5.4 through 5.6 is just one quiz for all 3 sections. And it's extra credit. Okay? So it's just one quiz.
Okay. But then is it going to be open Wednesday on?
So I was going to leave that, that one I would want it proctored. So what I was thinking then is you could take that during like on Wednesday where you have like an hour before class or whatever, that you would knock that out and then start on the chapter 5 test. That's kind of what I was thinking. Would that work?
Yeah. Could we take ours in the morning Wednesday?
Yeah, sure. Yeah,
Okay.
that would be okay. So
Was that
do you have a time, or do you want to email me
If we
now?
took it before school?
Do you want to email
That
me or
okay?
tell me now? Do you want to email me, or do you know now when you'd like to?
We could take it at 9 Wednesday morning.
Okay, so just the quizzes, or do you want to do the quizzes and then run right into the test, or how do you want to do that?
Just the quizzes.
Okay, so so at 9. So this is on Wednesday. So Winslow, 9 a.m. and that's just the quizzes. So quizzes 5.4 through 5.6. That's just one quiz. Okay. All right, and then during class time on Wednesday that's when I'm expecting everybody to do the test. Okay.
Is that quiz gonna be 10 questions still, like normal?
Is this the 5.4 through 5? I don't even know how many questions it is, to be honest with you. I forgot. Let's see if I can. Okay. So 5 questions. So 5 questions. So there's just, over 3 sections. So I'm just going to pick my favorite things. Okay. All right. Anything else about this week? Okay. Questions about the final or the evaluation or any of that? Okay. All right. Well, let's go on to the the last part of 5.6. What's so funny?
Mr. Strong, for the final, what
Yeah.
sections do we need to go over the most? Because we've heard 2 and 3 and also 4 and 5, and I think we're all confused on what we really need to study.
2 and 3 and 4 and 5. Well, I mean, I would say study a little bit of chapters 1 through 6. But the emphasis is since the midterm. So, but everything that we've covered is fair game from the beginning of the semester. Okay? But I will, I cut back a lot of questions, and so there's a definite emphasis since the midterm. So I would say chapter 4 and 5 would be your first priority. Why do I keep? Okay, sorry. I'm trying to talk and do this at the same time. I can't do it. Okay, so chapter 4 and 5 would be the best priority, and then I would go probably, 6 and then 1 through 3 is a second priority. Okay, so let's. We were talking about finding the area between curves. All right. So we were on practice 5, I think. And so, this says find the area of the region in the first quadrant that is bounded above by the square root of x and below by what the x-axis and the line y equals 3. Okay. So I'm going to teach you 2 different ways to do this problem. And they both have their advantages, and it'd probably be a good idea to learn both because of what we're going to be doing down the road. Okay? So the first idea is, see how, when we're doing our little rectangles, and you see what happens at this vertical line is that the bottom function changes. See here, it's just the area under the curve. Here, for this part, it's the area between the 2 curves. So what that means is that we would need 2 separate integrals. Okay? Now, you see where it changes here at x equals 1, 2, 3, at x equals 3. So we're going to have our first integral to be the integral from 0 to 3 of the square root of x. So that would give us this area right here. Now, to get this area right here, I would have to take the top function minus the bottom function. So that would be the square root of x minus x minus 3. So I'm integrating that from 3 to 5.303. Where did I get that? Well, it's the x value where these intersect up here. So after you put them in the graph, then you get the intersection at 5.303. So that's your second integral, would be the top function minus the bottom function. Okay? All right, so any questions on the setting up? Okay, so now I would like you to calculate, using your calculator, calculate the final answer. So you're going to do these integrals in your calculator separately and then add them up. All right? All right, so Chloe, when you have the answer to the first integral.
I got 5.489.
Okay. Oh, dude, was that your final answer?
Oh yeah, sorry. Was I only supposed to say the first one?
I was just gonna do it bit by bit, but that's
Oh yeah,
fine.
I did get 3.464 for the first one.
Okay. So, 5.489 is the final answer. Okay. All right. Now, what I want to do is show you a trick that on the calculator that might be helpful. So, like, let's say with this integral. So, if I'm going to put in the square root of x, so here's the square root of x, and then I'm going to just graph that and look at that from 0 to 3. Well, actually, okay, I can see it 0 to 3. So if I just want to have the area, okay? So when you want to just find the area and not necessarily the integral, okay, let me show you another way to do it. Okay, so just watch up here for a second. I've got the graph. I know I want to find the area under the curve from 0 to 3. So if I do second calc and then the integral at this point, so option 7, it's kind of cool because then, see, the lower limit is 0, and then the upper limit is 3. And so then it actually shows you under the graph exactly the area that you're finding.
Mr. Strong,
Yes.
how do you change the limits on your calculator?
What do you mean the limits?
Did you just put 3 in there? Or?
Yeah.
How do you do that?
It asks me for the upper limit and the lower limit.
I think. Oh,
Okay.
I see it now. Okay.
All right. So that's just the first one. Okay. Now it's a little more complicated when you find that to do the second one, because if I just do this graph right here, it's going to do this graph. And so when you type that in, you're going to see you'll see a different graph. You know, what you're trying to, let's see. Let's go ahead and put that second one in there. So if you want to try that with me, so because we're subtracting, it's going to graph the difference of those functions. So, but let's go ahead and put it in. So the square root of x minus parentheses x minus 3. Okay? And so there I'm just graphing that. Okay? And so now I need to see that between 3, integrate that from 3 to 5.0303. So if I do second calc 7 integral, and so the lower limit is 3, and then the upper limit is 5.303. And so then it gives me that integral as well. And so when you're finding areas, I really like this, doing it this way, because it shades what it is that you're actually finding there. Okay? So again, the big idea here is that we're we have to cut this up into two integrals because the bottom function here is the x-axis. Here the bottom function is a different function. So you have to subtract. All right, so any questions on the setup, on these two integrals, or actually putting it in the calculator? Any of those issues here? Okay. All right, now, the other way to do this problem is to integrate with respect to y. Now, see, we've never done that, but the issue is the rectangles will be horizontal instead of vertical, okay? So you imagine these are your rectangles, and instead of the width being dx, they're going to be dy. And so your function is all going to have y's in it, not x's. So, horizontal rectangles. All right, so if we take this same graph, see, instead of drawing our rectangles, and we had to cut it into two integrals, now if we make our rectangles horizontal, then see, it's just this function over this function. Now, from left to right, the functions increase along the x-axis. So this is like the biggest function over this one, all right? So what you have to do is you have to solve each of them for x in terms of y. So y equals x minus 3. If you solve that for x, that's x equals y plus 3. And then this function was y equals the square root of x. So if we square both sides, we get x equals y squared. Now, the limits of integration, remember the dy's, we're going up the y-axis now. And so the limits of integration are from 0 to the y value here where they intersect. So you do the second calc intersect, but it's the y value. 2.30, I would probably do 303. But it's this right function, y plus 3, minus the left function, which is y squared. All right, so we don't need that. Okay, so the cool thing about this is now we can just do it with that one integral, find the area. Okay, now, when you're putting that in your calculator, you can actually use any variable you want. It doesn't have to be y. So you could go back and change it back to x, or you could use y, or you could use any other variable you wanted. Okay, so, but put this in your calculator, and you know you'll get it right. You have it right if you get the same answer that you got in practice 5. You should get the same exact answer. Well, rounded to 3 decimals. Okay, so Anyone have any trouble getting the same answer? Should get the same answer that you got in practice 5 with the 2 integrals added up. Should give us the same answer here. Okay, anyone having any trouble with the setup, with the calculator, anything? Okay, so we're going to skip the last part here on this section. And so that's it for 5.6 and chapter 5. All right, so let's go on to chapter 6. Okay, so chapter 6 is just all about applications of integrals. So what I try to do here is try to show you some different situations where you might use an integral to set it up. So our goal is to help you be familiar with how we set these problems up and be comfortable putting them in the calculator. So with the different formulas. Now, so the way I used to have students go through chapter 6 and do a formula sheet. All right? But instead of that, what I'm going to do with the student success organizer, hopefully I'm going to help you organize a lot of the formulas in here, and then to eliminate most of the work. Okay, so we'll just see how it goes. All right, so the first one. So to find a volume using a cross section. So of a known solid of a known integral cross section area, A of x, from x equals a to x equals b is, so the volume is the integral of the area. Okay? So it's kind of like this. You know, when I was in high school, I got a part-time job working at a grocery store, and a lot of times I'd work at the deli. So you imagine like slicing meat at the deli. Well, if you could find the area of one of those slices and multiply it by the length, then you'd have the volume. Okay? So it's just, you find the area and multiply it by the third dimension, whether it's height or length or whatever you want to call it. All right, so to calculate the volume of a solid by cross sections, okay, you sketch the solid and the cross section. Usually it's pretty obvious. Like if you have a rectangle, a cross section, if you have like a pyramid, the cross section might be a rectangle, it might be a square. Depends on what the dimensions are. Okay. Find a formula for A of x, the cross section. So what that means is that you have to read the problem carefully or look at the picture to see, is the cross section a square? Is it a circle? What is it? And then whatever that formula is, you find the limits of integration and then integrate to find the area. Okay? All right. So, this, the hardest part of these is just to understand what the problem is telling you. Okay? But like, let's say that we had a pyramid and its cross section is a square. Then, see, you draw the pyramid and then the cross section is a square. Well, it's the area is side squared. And so let's say if the height of the pyramid is 5 feet, see, all of those cross sections would be squares from 0 to 5. And so you integrate that, and that would be your answer. Okay? That would be the volume. All right, so practice 1 says a pyramid 5 meters high that has a square base is 4 meters on each side. The cross section of the pyramid perpendicular to the altitude x meters down from the vertex is a square x meters on a side. Find the volume of the pyramid. All right, so let's go. So what would be, so the cross section here is going to be the square. So actually, is the area that we want for practice 1, I mean, are the limits of the integration would be from 0 to 5, or would they be 0 to 4? Read the problem and see if you can figure out what would be the cross sections would go from 0 to what?
Mr. Strong, we don't have the problem on our paper. Did I send this wrong thing again? Did I send you the lesson?
No, this
we're
is
not sure.
we have this. We just don't have the problem about the pyramid. We have the rest of it, I think.
Okay, gotcha. I'm looking at the wrong thing. Oh, okay. So no, I just added that in. I'm sorry. I added that in. So I want you to write this in the margins here. So like here you have the pyramid, and the cross sections go from 0 to 5. So that's your limits of integration. And so then if the cross section is a square, then it's x squared would be the formula for the area. All right? So that's just the idea of it. Okay? Sorry, that was my mistake. All right. So let's look at the next one. The formula for finding a volume using the disk method is pi r squared. Let's okay. So that's pi f of x squared. Okay. All right. So let's see if you can understand what's going on here. Okay. So here we have a curve. Y equals the square root of x plus 3. And see, we rotate it around the x-axis. And we want to find that volume. So how would we do that? Well, we actually use this because when we rotate it, it's going to become a circle. And so it's like the cross-section method. The cross-sections are these circles. And their area is pi r squared. But see, the radius is going to change with whatever the function is. So it's actually pi times the function. The function is the radius at any point from A to B. And so in this case, the A to B is 0 to 9. So it goes from 0 to 9. So see, when you rotate the function, it's like it makes like a Christmas ham. I don't know why I'm thinking about that, but anyway, so from 0 to 9. So you imagine your cross section, it's like your deli slices. you're adding up the areas, pi r squared from 0 to 9. And that's your integration. Okay? So let's see if you can do that. So put this function square root of x plus 3 in here for f of x and integrate it from 0 to 9. Let's see if you can do that. Now the pi is a constant. So you can bring it out front or not. It doesn't matter. It won't affect the answer. But this is what your integral should be. So the integral from 0 to 9, and then you have the pi either in front or inside, and then the radius is the function squared. All right, so Rachel, when you've got an answer.
I got 720.995.
Excellent. Okay. So I did the integral and then multiplied by pi. But you can put the pi in the integral. It's all good. All right. So great job, Rachel. Any questions on that? So as you're going through chapter 6, what you're going to want to do is find the formula, either what we write down on the paper or in the book, and then look through the practice problems or the examples, and then see if you can do it. But I'm trying to give you the practice problems similar to what you'll see. Okay, now the axis of revolution does not have to be the x-axis. So the formula is pi, well, okay. If you're going to revolve around the y-axis, it's going to be pi and then f of y squared dy. So the radius, it could go around the y-axis. So in general, I just say it's pi times the function squared from a to b or c to d or whatever. Okay, so let's see how that looks, what that would look like. So it says find the volume of the solid generated by revolving the region bounded by y equals the square root of x, and the lines y equals 2, x equals 9, about the line y equals 2. Okay, now that looks a little complicated. Let's see if so here's the square root of x. Y equals 2, so he cuts it off. So you have this tiny little region. And you're revolving it about y equals 2. So it's creating like this So it's like it's creating like a little bullet. I'm not drawing the bullet very well, or a little cornucopia, I guess would be better. So it's rotating around this line, forming a three-dimensional object, and we want to find the volume. All right, so how do we get this distance? Well, again, it's pi r squared, but the radius is not necessarily the function, because the function goes all the way up to square root of x. This distance is 2, and so the actual radius is the square root of x minus 2. Okay, so now how do we, so the limit of integration, we have x equals 9 here, but how did I know it was x equals 4? How did I know to start the lower limit there and not at 0?
Because y equals 2, x equals 4.
Right. So it's the intersection of those two. So the square root of x, and then when y equals 2, then x is equal to 4. You square both sides. So then that integral is going to give you the volume here. Okay? All right, so let's see if you can do that. So go ahead and put that one in your calculator. Let's get an answer. All right, so Skylar, when you've got it.
5.75.
Okay. All right, good. Any questions on that? Okay, so rotations about the vertical axis have cross sections parallel to the y-axis. So this is kind of what we were talking about at the end of chapter 5, if we rotate about a vertical axis. Okay, so this says find the volume of a solid generated by revolving the region between the parabola x equals y squared plus 2 and the line x equals 4 around the line x equals 4. All right, so to try to figure out the graph, let's get rid of this. Okay, so x equals y squared plus 2, that's a sideways parabola. And and the line x equals 4, so that's a vertical line. So we're going to rotate it around that vertical line. So then we take the integral of the area. But we're going to use these horizontal rectangles. And so here's x equals 4. So each rectangle is going to have a length of 4 minus y squared plus 2. So that's the right minus the left. So that distance. So that's going to be the radius. And then we integrate that from negative radical 2 to positive radical 2. Why? Because those are the y values. So it goes from here to here. So how I got that was if I set y squared plus 2 equal to 4, see, I'm trying to find out where those lines intersect. So if I set those equal to each other and solve for y, then they're going to intersect at plus or minus radical 2. And so then those become my limits of integration. All right, so let's put that one in. Let's put that in the calculator now. All right, so Chloe, when you've got it.
18.956.
Excellent. Okay, so I'm feeling really good. Here, what I'm feeling really good about is your ability to use the calculator and setting up these. These are fairly complicated integrals, and you guys are nailing it every time. What we need to do tomorrow, and hopefully a little bit on your own, is just practice setting these up, because that's really where the work is just setting up the integral, because it seems like you guys are doing great, and once we get it set up. So that's going to be kind of our goal tomorrow. All right, let's see if we can set one more up. Okay, so the formula for the washer method is pi times the integral from a to b, and it's big R squared minus little r squared. Now, what that means, see, we're going to have a washer. So if there's ever a hole in the area, when we rotate it, if the area isn't adjacent to the line of rotation, then it's going to have a hole in the middle. And so it's going to be like a washer. So pi big R squared minus little r squared. So the big circle minus the little circle. And if you factor out a pi, that gives it to you. Okay? So I guess we're running out of time, so we're not going to have time to set up the next one. But we'll